Hey guys, change of base is today's heading. So, we've previously looked at the fact that on our calculator we have two buttons. We have log and we have ln. We know that this has a base of 10 and this has a base of e, the natural log. So, what happens is we started looking at ones that didn't have a base of 10 or e. So, we were looking at ones like log 2, 8. And we said, oh, well, we can just turn it into an equation. And if we use that little trick, little number to the power of the answer equals the big number to the power of x equals 8, then we could solve it and work out the value. But that was only working for these ones where we got a nice number, where we had the square or the cube of a certain number, okay? What we now look at today is what happens if they're not nice numbers? What happens if I, instead of having 2 to the power of x equals 8, where it's nice and easy, what if I had 2 to the power of x equals 106? It's not a nice number. Or 2 to the power of x equals 7.3, where I guess you could play around, guess and check and get maybe x to a rough number, an estimate. But what we do is we use a change of base formula, where we can actually work out these to the amount of decimal places we ever want, well, what our calculator shows us. So using this formula, it just says take log of b and divide it by log of a. So this is our natural log. In other words, log of the big number over log of the small number. So if I need to work out 5 to the power of what, because remember that's the same thing as, well, let's follow this formula. I'm going to do ln of 5 over ln of 2. And if you throw that in your calculator, oops, sorry, I've messed it up already, log of the big number. So you'll have log 2 over log 5. Now throw that in your calculator. So it's always log the big number over log the little number, or log the number over log the base. And you should get an answer of, to 2 decimal places, 0.43. And you can always check it. If you sub 0.43 into where x is, 5 to the power of 0.43, you'll get a number very, 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 very close to 2. If I didn't round as much, it would be even closer. But that's it. So now we could evaluate any log we want using this formula. Now, I do want to show you another way this can be done, okay? So instead of using the change of base, so this first option uses our change of base formula. The second option is going to log both sides. Now, I often use a variety of both, but when we get to more worded problems, I always go to logging both sides. Logging both sides, we use it when we have exponential form. So we know that log 5, 2 is the same thing as 5 to the power of x, which x being what we want to find, equals 2. Now, if I log both sides, and you can't see me, but I'm using inverted commas. So let's look at what that means. Now I'm doing the natural log. So like I said at the start of this topic, you're going to mostly see we're always using the natural log, log of e. So if I log both sides, it's kind of like timesing by a log, but it's officially not. So I'm going to log both sides. Let's look at what that would look like. It's going to be ln of 5 to the power of x, and that's equal to log of 2. So I've just logged both sides of that equation. Now, let's think about this. I know when there's a log and we have a power, that's the same thing as it timesing out the front. X timesing by ln of 5 equals ln of 2. So that's just using your log law that a power comes out the front and multiplies. Now, if I want to just solve this equation for x, I'm going to bring the log 5 over and divide it. And what do you know? We have our change of base formula, which we jump straight to in using it to start with. So it's kind of like the proof to the change of base formula, if you like. It's definitely important to know, but either way works perfectly fine for these questions. So let me give you a harder question. So call this one B, and let's go, I want you to calculate 6 to the power of x minus 2 equals 20. I want you to solve for x, okay? And get your x to 2 decimal places. So pause the video here and give that a go, otherwise I'm going to jump straight to my answer. So depending on which way you wanted to go about this one, you could have done it as a change of base or logging both sides. I'll show you both, okay, in case you were doing either one. So if I did log both sides, that one probably comes quicker to me because it's already in exponential form. So I'd have log of 6 to the power of x minus 2 equals log of 20. And when I have a power, times out the front, so x minus 2 timesing by log 6, so that's that whole thing, equals log 20. And then, cleaning this up, I'm just going to take my log 6 to the other side. And then my final answer I get log 20 over log 6, I plus 2. Now, the other way you could have done it is by rewriting this in log form. If I rewrite that as log form, well, that would give me log 6, 20 equals x minus 2. Okay, and double check it, because that would be little number to the power of the answer gives me the big number, and that's what it was. And now, just doing my change of base formula, that tells me that, well, x minus 2, just doing change of base on this log 6 of 20, is equal to log the big number over log the little number. And then, of course, bringing the 2 over, you have the exact same thing as the other one. Does not matter for now which one you do. So hopefully you got 3.67 to 2 decimal places. Now the best thing about these is you can always check your answer. Sub that x value in where x is in the question, and you should, because we rounded, you might get a number with a few decimal places off, but it should be very, very close to 20. So that's it today. That's for now all I want to be practicing. I will give you one more just to show you if they give you a question where it might be, let's say, 7 minus log 3 of 100. If they give you something in that form, just put it equal to x, throw everything but the log onto the other side. In this one, I'm probably going to throw the log on this side and take the x over this side so I have a positive log just to make my life easier. So then I get 7 minus x is equal to log 3 of 100. From there, you can do your exponential form and then log both sides, or just change your base straight away. But the idea is if they give you a question that's got other things around the log, just remove everything else to the other side before you change your base or do your exponential equation. Okay, so today's exercise is still on exercise 805. Now, technically this, what I've shown you today, change of base, is a type of log law. So that's why it's still in 805. I want you to do question 11 all, and then go to question 10 all. Start with question 11 because it's more to do with today's lesson, but then go to question 10 after that, please. All right, thank you. See you guys later.